Yeah, thank you all for coming here, and thanks for the people on Zoom to attend. So Ricardo did the introduction. I guess I can jump right into it. I'm doing a PhD in Coimbra, Portugal, and I'm here on a Fulbright grant. My supervisors are Amilcar Cardoso and Matthew Davis, and the title of this presentation is "Snap, Clap, and Slap." From taps to drums with AI timbre transfer. Just a little about me, I guess. Yeah, I'm from Portugal, more specifically from Alentejo Litoral. That's my hometown there, a picture of my hometown. I'm Fulbright, yeah. Also, I'm a drummer that's at Izmir this week, and I also play basketball. So if you guys like basketball, please come talk to me. And just like very broadly about my research fields. The two main fields are computational creativity and music information retrieval. I guess maybe some of you guys know here about music information retrieval. Computational creativity is more general in the terms of that it deals with all creative fields and about thinking about them from a computational perspective, and if we can do that or not. But let's not get into that, I guess. And more recently, I've grown an interest in human-centered AI as well, because I think it's really important and it really connects with what I'm trying to do. Just a brief introduction. Here's a quote from Brian Eno. It says that you can't really imagine music without technology. I very much embrace this quote in philosophy. And the thing is, technology is always evolving, right? And nowadays we can do stuff like this, for example. Not to say that we need to do this, okay, but we can. We can also just do things the old school way. And even like this outpainting is old school right now, right? This was like 2022, maybe. We're already in 2024. Who knows what's gonna come up? So this is very generally about like generative AI and generative tools, what we can do. More specifically, I'm interested about music and about rhythm, right? So I guess almost all of us here, when we feel the beat, we can like tap our feet, snap our fingers, not our heads. What drummers and percussionists do, and maybe some other musicians, they tap rhythms and they can emulate what they're hearing, or they can improvise over it. And that's very much a thing I've done since I can remember. And what I'm trying to do is can we actually turn that interaction into something more concrete, more useful with an actual output? Can we turn that interaction into, for example, drum sound? So that's my PhD in a nutshell. We can go away. No, but that's the very general motivation. I will go into a little bit of like just these backgrounds of how to do timbre transfer, or just some examples for you to maybe better understand what this means between converting between one type of sounds to another one. Here we can somebody whistling this melody from Indiana Jones. So more at all, they developed this universal music translation network where they were able to transfer from that whistle to this symphony or symphonic orchestra, I should say. There's also in 2021 a foundation, and maybe not foundation, but a very important model for audio to audio processing was released called Rave. And it's really important because it allows for high quality, real-time audio synthesis. So the two main parts is the high quality and the real-time. It's really fast. It also maintains really good quality. And it's for synthesis, but it turns out it does a really good job at timbre transfer. So you train a model on just one type of sounds, and it learns how to synthesize those types of sounds, but you can like prompt it, excite it with some other input, and it transfers from those to the type of sounds it was trained on. Here we can see Naoto Kui of Newton, company that has dealt with some of this stuff as well. kind of beatboxing and converting his voice into a percussion instrument. Now he's gonna turn up the dry slider at some point, and you're gonna hear more of what the actual voice, what he's doing. Yeah. I guess you could hear like him going like toko toko toko, and yeah. And this guy Rob Cloud, he also is using rave, or used a rave drum model as well, and he actually perfected it into a performance. So he's a musician, actually. He's not an engineer or researcher at all. And what he did was he had the model, and then he played around with just some audio effects and how he could, like, you can follow him on Instagram, but he, for example, one problem he has is that these models can be really flimsy. And so he had to buy, he called it the Britney mic, so that it also stays in the same place, so that it can be more controllable. And that's a big thing, controllability for musicians. So yeah, I'm just gonna play his clip. You can find this on his Instagram as well. I think you can see like the effects, like the bass and this echoey. And like he also admits it that he's not he's not a beatboxer. He's just like playing around with it. He's like more of a musician, and he wants to incorporate it in a way that he's playing another instrument and then using his voice to like do the rhythm. So yeah, so this is timbre transfer in a nutshell. And yeah, I'm trying to do similar stuff, but from tapped rhythms to drums or other sort of sounds, of percussion sounds. And yeah, this November at Izmir, I had a late breaking demo called From Taps to Drums, Audio to Audio Percussion Style Transfer, where essentially I trained the rave model on a drum data set so that it learned how to reconstruct drums, but then at inference stage, I prompt it with tap rhythms and see what it can come out at the end. So maybe, show of hands, who knows what a VAE is, or an autoencoder model here? One hand, okay. So very high level, an autoencoder gets some type of input, it encodes it in some way, and then it learns how to encode it and to decode it later on. It's very abstract, okay, but think of it as maybe doing a translation between languages where in the middle you have some sort of code. Okay, so like from German, for example, some code, and then from the code to English. Okay, that's what the encoder and the decoder do. We found some. Oh, yeah, I've got some examples for you. I can play like some drums here. These are the original drums. They're not the original track. I had to extract it automatically, but they do the trick. And this is my tapped rendition of what you just heard on a desk. Right. Which, I mean, to me it makes sense. It's the same groove, right? So they share some kind of language, right? Some rhythmic language. And then this is what rave outputs given the sound in the middle that I just played you. Right, okay, so you can see that there is some timbre transfer happening. It's not perfect, right? But it can kind of capture, and what's interesting is that it has never seen the type of sounds I recorded, like the taps, okay? We have some other examples. Actually, let me go first to here, where you can do some other cool things with this. So we heard the drums, right? This is the original song. This is Reptilia by The Strokes. And then, for example, I can remix my taps into the original song, for example, just for fun. Like my taps are replacing the drums. Very interesting, right? You can also listen to the taps plus the drum track on the same at the same time. And then we can also listen to the taps and the rave output at the same time. Now, one thing here is that there's a little bit of delay you might notice between my taps and the rave output. Let's see. It's a bit out of sync, right? But you can understand that it's more or less the same rhythmic pattern and the same groove. And yeah, finally we can replace the drums from the original song and put our reconstructed drums. It's also a little bit out of sync. And yeah, where was I? Here I have some other examples, just to so that you hear some other types of drums too. Okay. Let's see what it could come up with. You see that it's like kind of mushed, right? It mushes up some of the sounds, which is like one of the flaws still. But the initial idea is there, which is interesting. We also have some more electronic sound. It's a Portuguese song actually. This is my tap version. And the output. Now, okay, I'll go ahead to the findings. So yeah, I can start, I guess, these first two. So it's proficient in capturing the subtleties, which means like when I'm tapping, it can distinguish, even if I'm just playing on the same desk, it can distinguish kind of my performance of how I'm playing it. And that's why it reproduces at the output different sounds, which is really cool. At the same time, there's the drum sounds, they're not really, drum sounds yet, a little bit. They're kind of drum sounds, but they're all mushed. And I think one of the things is I'm training the model. The way you train a model, or this model at least, you just throw it a lot of drum sounds, and you don't tell the model these are snare sounds, these are kick drum sounds, these are hi-hats. It just like interprets them as sounds. So I think in a way it kind of averages all of the stuff together. And the drums, they're a problem because you have all sorts of different timbres in the same drum kit, right? Whereas, for example, if it would be a violin, if you play different notes, it's still a violin, right? Here, different notes correspond to very significantly different timbres, the snare, the kick drum. So I think that's what's behind all of these sounds being kind of mushed together. Yeah, it's unreliable given some input, so sometimes it doesn't really produce any output, the model I trained, but I think it's very much a problem with my model, not the architecture, because I tried some others and it worked. Yeah, and this is like a double-edged sword as well. Even though it's proficient at capturing subtleties, it's very flimsy, so it may be I'm trying to play exactly the same sound, or I want exactly the same sound at the output, but it's very sensitive to maybe some change and can be harder to reproduce the same sounds. Yeah, it's also better with kick drums and snares. I think they hit better. And yeah, I also forgot to show you, just for fun as well, I also trained my model on drum sounds and input the original drum track and see if you could reconstruct it back again, because that's what was the purpose of the model. That was how I trained it. And it should be here. Yeah, so listen to the drum track again. Now we have hi-hats, and here. So even with the drums, it's like some work still to be done, right? But yeah, okay. Then what I did was trying to dissect my model, actually go into what it was actually doing. First, let me tell you about just this little data set that I built with some colleagues, where they just tapped several taps on a table, and then they did something called onset detection, which, as the name suggests, it just breaks down each onset so that you can have the individual hits. And it's easier if I just play it. So this is like a colleague of mine just tapping on the table, different types of taps. And then this is stereo, I don't know if it's gonna work, but then we automatically assign an onset each time there's a tap. It seems really easy, like from a musical point of view, but computationally, it's not that easy. Like, it's interesting, but yeah. So yeah, each time there's a beep, it means that it's detecting an onset. And then if we detect the onsets, we can like break several onsets. A file that has 10, 20 onsets, we can break them into individually 10 or 20 onsets, right? Okay, are you still with me? Yeah? Because, okay. Right, so because we're gonna go into the hard part now. So remember, an autoencoder is something that gets an audio input, it encodes it somehow, and then learns how to decode it as well. There's the encoding and the decoding part. In the middle, that coding, or that code, if it was like between two languages, like I said, there's something called the latent space. The latent space is this, it's the code. It's how you represent something without having to represent it all at the same time. It's like you encode it into this latent space, which reduces some of the dimensions, or it just learns how to use the minimum amount of dimensions possible to represent the audio. Whereas like the audio as a raw input has many dimensions, so it's very computationally heavy. Okay. For example, I guess with examples it's better to understand. Here on the left side, we can see the embedding or the encoding, the same thing, like the fingerprint, let's say, of one-shot kick drum, okay? And you can see it's one-shot because after some time, it goes down to 0, right? Here, no color change, right? The one-shot hit is only being activated at the beginning. And then it's in a non-trivial way. It's not like, oh, it's a kick drum, so it's only the 0 dimension here that activates. No, they all laid up, and then they switch around. Like black means really high, but then like the 0 goes to really low. So it's numbers. It's really hard to interpret for us as humans. What we need to understand is that, or when we need the intuition we just need to get is it's being activated, then it evolves in some non-trivial way, and then it dies down because the sound went away. Okay, on the right side, it looks like a checkerboard, but that's not a one shot. Okay, there are several hits. So what I mean to show by that is like if this is complex with just one note or one hit, if you string together several taps or several hits, it becomes even more complex of how the latent space represents these sounds. Okay, right. Yeah, and again, this is kind of a fingerprint for this one shot. Okay, if it was another shot, it would be more or less it would be a different fingerprint. Now, what we can do is we can take this data set of single one-shot taps, we can pass them all through the encoder, so we get as many fingerprints for as many hits we have, let's say 20, and then we can like do some plots some averages to see how the different latent dimensions represent those taps. Are you guys familiar with this type of plots or not? Not really. Yeah, more or less. So essentially, it's like this is the now I have to explain these plots. Okay, but you have the lower bound and the maximum bound. So every value is between that there. Then the line in the middle, it's like the average, and the boxes show the I think the first quartile and the third quartile, and the little dots are outliers. What we need to retrain from this is I passed all of the one-shot taps through the encoder, and then I did some statistics like the average to get this box plot. And for example, when I pass all of these taps through the encoder and look at only latent dimension number 8, which would be 7 here because, well, numbers change. We start in 0, but it doesn't matter. The last latent dimension, you can see that both the average or all the average, the maximum, the minimum, they're very, very close together, which means that for any type of tap that I put through the system, that doesn't change that much. So that dimension doesn't tell us a lot about how different taps are different from each other, okay? On the other hand, latent dimension 2, you can see that it's maybe the most different for different taps. So this one is what distinguishes one tap from being another tap in the latent space, okay? So one fingerprint being different from another one, okay? And then what we can do, this is kind of, I haven't explored this as well, but it's just to get an idea of how different dimensions activate or not, or change for different types of sounds. Then what we can do too is we can, instead of passing taps through our system, we can pass drum sounds and plot those in the latent space. So I just got a data set of one-shot drum sounds, so kick drums, snare hits, hi-hats, all types of sounds. You can pass each one through the encoder, and that will give us a fingerprint for each one, an embedding, right? And then we can plot these to look if they are close together or not. Now, there's a problem because we don't see in 8 by 22, we see in 3D, right? So we need to reduce the dimensions into something that's plottable, okay? That's what UMAP does, UMAP or either TSNE. But we just reduce the dimensionalities so we can plot in a graph, okay? So what's the trade-off though? We lose information, right? We're squashing 8 dimensions or 8 by 22 to just 2 dimensions. So we lose information. We cannot go back from this to the original, okay? This is just for visualization purposes. But it's still useful because what we can see here is, okay, let me tell you about the colors. Again, I passed a lot of drum sounds through the system. The red dots, the red dots are kick drums. They're labeled as kick drums. The green ones are snare hits, and the blue is just other. So I just did like these 3 classes. And we can see that for a rave model that was previously trained on drum sounds, it can cluster them better, right? So there's a better cluster of kick drums, better cluster of kicks there. The snares are all over the way there, even though, like, for example, here it kind of becomes like there are some others that sound like snares, some snares that sound like others. But you can see there's a lot of white space, right? So they're better far apart, each type of sounds, which means the model learned to encode them more separately, more better, I guess, in a way. Whereas this here is another rave model, but that was trained on darbuka sounds, not drum sounds. Okay, so a different instrument altogether. And if we pass the same drum sounds, it can encode into the latent space. It can try to figure out what's the embeddings for these drum sounds. What happens is, since it has never seen those sounds, the the clustering it does, the representation, it's way more sparse. It's okay, even if here they're all stuck on top of each other, here they're more spread out across space. And even like the distinction between snares and others, here there's a line clearly here, right? But it's kind of more fuzzy. Now, just a caveat about this. UMAP is not a linear transformation. So what this means is if you run UMAP several times, you can get several different results at the end, okay? Or yeah, different results. And also, if you noticed, if you have a sharp eye, the axes have different scales, right? Different numbers. The problem is, and this I actually have to do some more learning on this, is I don't know what that means because it's not guaranteed that this was the same transformation. Sorry, Ricardo, I really need water now. Can I get water?
I guess so.
Yeah, but you said you cannot drink water here.
Yeah. Just go out and grab a drink.
Okay, so we'll do a timeout so I can get water, otherwise I cannot continue. Okay, sorry. Yeah, it's right over there, right?
I made it up to that, Ricardo. No liquid policy. That was funny. Are you there?
Yes, I'm here.
You didn't like my comment, obviously.
No, it's okay.
Oh, I think that's fine. I'm just kidding.
Yeah, sorry about that, guys. Okay. Hope I didn't lose anybody. Right. So we can plot the same sounds to different models, and we can see how differently they are. What's cooler even is that we can make these plots interactive. So here I have it's actually another drum model that I got access to, but this is the same latent space, and there you can see I can hover them. I see which file this is. This is bass drum, clean medium, whatever. But we can hear them, right? We can see like where different kick drums are being placed in this latent space. And then we can go over to the snares too. And also like you can see there are these two different clusters of snares. You would like have to see how different they would be or not. And then funnily enough, you have these little ones that can be close enough. This is labeled as a bass drum, and this is another, but it's clearly a low tom, right? And you can see like perceptually how similar they are, right? Also, the purple cluster are my taps, the first data set I had. Okay, so we can see how they compare to the rest of the other types of sounds. So if I click on these, yeah, I need to maybe see. Okay, and yeah, they were clustered more or less all here. That's not all though. We can actually see, we can hear the output of the rave for each of these sounds. So if we listen to this kick drum, okay, that was a bad example, but okay, so this is the output of a rave for that particular kick drum. And we can do for snares too. Okay, so rave, the only thing is rave, it doesn't really work for transient like hits. So percussion is very transient, which means it's very short. It works better for like violins or melodic stuff that holds a note, instruments that hold a note. That's why it's not, sometimes we get this, which is almost inaudible. It's like, there's actually, I don't know if you can hear it, but we can also get, hopefully, some snares in the output. not. Okay. I'm not wanting to cooperate. I'm not finding good snare. Okay, let's move on. We can also do the same things for the taps, which is, yeah, again, very inaudible. See, there's something there, a little bit. Okay, see, this tap, which is, here the tap is more inaudible than the output, actually. Oh. Anyways, so, if we can plot the different types of sounds, can we manipulate them? In theory, yes, and that's what I'm working now, is that, okay, we have our taps here. If I know that this tap should be a kick drum, can we drag them there, and then maybe this tap, if I want it to be a snare, can I drag the dot there? That's what I'm gonna be working on here, actually, or right now, the next thing I'll be working on. Yeah. Okay. Let's see. Now for something completely different, as Monty Python says. So this is another work I did with my colleagues, which has nothing to do with what you've seen, with drums or rhythm. The only thing it has to do is it's about co-creative tools, let's say. And here we did a qualitative study where we met with some artists to understand, to try and better understand what needs did they have, what needs did they not have, and how could us as researchers and builders of these types of tools help them, right? Because it's a little bit harder than just like sitting people down and say what you want, because people don't know. If people before the wheel would answer what you want for faster means of transportation, faster horses, not the wheel, for example. So it's like it's hard to get around the question. Yeah, again, I'm gonna go through all these slides a little bit faster, I guess, just so we have some time for questions. But yeah, so these tools like ChatGPT, Musical.ly, DALL-E, all these new generative tools, they're all built by these companies, but like, where is the artist in the process? Were they consulted or not? Like, how are we actually helping them or not? And so we started with these research questions of, okay, how do creators think software can help them in their creative tasks? And what methodology can help overcome some of the challenges of collecting needs for creative software? Now, it's a bit wordy, that sentence, but what it means is that what I just said, you cannot just sit them and ask them stuff. You need to kind of get into their workflow and better understand their workflow in a way that you can extract needs from that, okay? So yeah, just a little bit of related work. So if you're from software engineering, maybe you know about requirement gathering, which should be the first step to actually know the functional requirements before building software. But there's not a lot requirement gathering for creative systems or co-creative systems. There's also the field of human-computer interaction, and there are several studies there, but they usually do not involve users. They're more theoretical, and of course they're valuable as well. It's just a different thing. And there was a little bit of adaptation from HCI to computational creativity, but it's also all theoretical, adapting some framework from HCI to CC. Yeah, you also have qualitative studies, but again, the interviews alone are unable to capture the creative process elusiveness, and they focus usually on specific systems and particular aspects. And then there's this other tool we can use, which are cultural probes, they were designed in the field of design, I think, where you would give people this package of tools, and they would create with it, and then you would collect back what they would do with it. It's very generic, I guess, that description, but the important thing is that it was designed by artists and with artists in mind. So we divide something called POCA. POCA, our little guy there, it stands for Pocket Artist. and it's just a virtual cultural probe via WhatsApp. I'm going to explain that a little bit better in a second. But so POCA, we told our artists that it was a co-creative companion with seemingly limitless capabilities. So we told them, think of POCA as somebody or something that you can ask whatever you need for your creative needs. Now, of course, POCA wasn't actually anything. It was just a WhatsApp number. Okay, so it was them trying to speak with this entity and sending messages so that they would record what these needs were. That's why it's a virtual cultural probe. So it was just like a via WhatsApp. Now the cool thing is that it can capture the artist's needs in the wild, right? So they can be under workflow, just pull their phone and say, oh, I would really love if I would have this harmony for this melody or whatever, or for it can be anything. It can be for a writer too. Give me ideas about a poem about sunlight or whatever, right? And it doesn't need to be even these examples, and that's why we went and talked with the artists. Now, yeah, it can seem, even when we were explaining this concept to the artists, it could seem a little bit vague and abstract because it can do anything, or like what can it do or not. It was confusing to them. Also, this was before ChatGPT even existed. This was like we did this in May 2022, so there was even less of an idea of what these tools were capable of. So we did tell them, okay, if you get lost and you don't know what to do or how to interact with POCA, think about these two questions to anchor yourself. How can a creative machine help you? Or how can a machine help you be more creative? And we left to interpretation whatever those questions meant to the artist, or those words, I guess. So for data collection, we did an introductory interview with all of our participants, just to explain the concept like I did here and ask some demographic questions of what was their field of expertise. We then let them interact with POCA for a whole week, and then we did a final interview to collect more data and to understand how the week went for them and how and when did they interact with POCA or not. I'm afraid I have to go drink some water again, which is annoying, I know, but you can read a little bit about the data analysis if you want. Sorry about that. Okay, so the data collection was simple enough, right? So we just interviewed some people, let them work with POCA, and then did another interview. The analysis is not so much. We interviewed a total of 21 people, but we were only able to analyze 15 of those, which results in more or less 18 hours of audio interviews and 102 direct interactions with via WhatsApp with POCA. Now the thing is, this is a qualitative study, and it's not a survey. They don't have like little multiple questions, multiple choice answers, right? They could answer whatever. So it's hard to go through that type of data. What you have to do is some thematic analysis, which essentially is just going back through the interviews and seeing, okay, here they spoke about school and classes or teaching, so maybe there's a connecting theme there. Or here they talked about, it would be cool to, like, if it could complete my work in some way, whether it be like drawing or writing or whatever. And you kind of have to connect the dots. And to do that in a scientifically valid and systematic way, it's a lot of work. That's why we weren't able to analyze all of the data, even if we were 3. And also, we were looking at needs, right? But that's very general. So first we just analyzed 3 participants and we segmented all of the data into units of meaning. So just like, okay, this is a need, this is a need. And then we try to do some connections between them. I don't have much time, so I think I'm gonna maybe not get into all the details, but essentially we did a pilot study to find the initial themes, these 9 initial themes, and then using those 9 themes, we can go through the other participants and this goes to this theme, that theme. Problem is 3 participants is not enough to do a proper pilot study, so we found out a lot of other themes, and yeah, you can read the paper if you want to know more about the methodology, but I think what's more interesting to talk about is the findings. So in the end, we ended up with these 2 big categories of themes. One is the user needs themselves, and the others are the context of use. So what are the user needs? There are roles that Poca could fill or could step in the shoes of. For example, Pocket could just simply be a recorder for their ideas, very basic, or as you just jot down some ideas, some musical ideas or something in your notebook. That's a need. I mean, it's a pretty basic need and it's more or less solvable, but we found that out. The more interesting ones are maybe the generator or the variator. I think the variator is a good one where you would give some kind of input, creative input, and you would ask for some variation of it. For example, so let me change this image into so that it is nighttime or something. And yeah, we also had some more the completer is interesting. The critic was also interesting because artists would sometimes ask for feedback from Poca, but subjective feedback. They wanted an opinion on what they were doing, which was interesting. And yeah, just sometimes to brainstorm ideas. Yeah, they also would resort to Poca for that. Now, these user needs, these roles that Poca could play, they're more or less separate of this context of use. So context of use is just, it is what it is. It could be for inspiration, it could be for idea, it could be for skill development, it could even be for personal life. For example, we would have people just ask for, oh, I have this in the fridge, what can I cook? So we consider that part of their creative process because we consider almost everything as part of the creative process. But for example, in terms of productivity, was the context of use that was brought up many times of we would think they would think more about the creative doings, I guess, but even oh, I don't have time to organize this and that. If Poca could do that, even its scheduling and stuff, they would ask for that kind of stuff. Yeah, I don't really have time to go through the quotes. Sorry about that. We also had these other 3 different teams that didn't fit that. The first one was more about interacting with it, not only the what, but the how. So I want this to be generated, but how? Is it a photo, or is it a computer? Is it that's a bad example, but for example, or do you want a description of the photograph? I guess doesn't make sense, but you know what I mean. It's how would you get back, and how would you interact with it? Not only the what. The non-necessity theme is that some participants opted to not use Poca, so it's very important that we understand when do they want to use it and not. But at the same time, thinking about Poca throughout their week allowed them to better understand their own creative process. And then they had a lot to say about the methodology, that, for example, a week was way too short, and yeah, but that it fostered creativity and changed the perspective of creative technologies. On the flip side, another negative point was that Poca was very ambiguous and underwhelming because it didn't actually do anything, right? So, yeah, so our contributions were this novel methodology capable of capturing needs in a while, as well as a posteriority and necessity, and these general themes which inform what artists want and need from their current and future tools. At least that's what we found. yeah, I just put this is an AI generated image from DALL-E where I just put like researchers interviewing artists so that we don't forget about the artists in all of this in building tools. I guess you're the wrong audience. This was for more of a research audience for researchers, but yeah, I think it's a nice message. Right, we're getting to the end. This is just some questions that if you want to talk about to me or to want to speak with me about, there are just things that I think about, like how can we build more human-centered tools? What does it mean to have AI as a co-creative partner? What does it mean to democratize creativity? Because, for example, throughout our studies, we found out that, for example, the musician was like, oh, I don't really want AI music tools, but I would really love AI painting tools because I cannot paint. And then you would go to the painter or the drawer, is like, oh, I don't want that, but I would like AI music tools, for example. So, to give everything to everybody, like it's hard to think about it. Oh yeah, and like I have a little nugget, I guess. So at Izmir, it's pretty much a music conference, and so people there are researchers, but they're also musicians, most of them. And there's a jam session every year, and I played some tunes there with some other fellow researchers, and we actually did something which was to use ChatGPT to change the lyrics of some song to kind of make it funnier. And yeah, we switched Fear of the Dark to Fear of MATLAB by Iron Maiden, and here's just like some of the lyrics of the song, and here's I guess to wake you up a little bit. It's our performance, actually filmed by Irmak, I think. She's in the room. Yeah, and that's it. Yeah, I have this link tree here with my GitHub, Twitter, if you want to connect with me. Yeah, I also, last October, I did this opinion article for a Portuguese newspaper. They allow us to publish. It's about being a PhD student in Portugal. It's in Portuguese, but you can use ChatGPT to translate it if you want. And I would love some international students' feedback on that, actually. And yeah, this other little project, this was my master's thesis. I converted images to sound, and I'm just gonna play that back while we finish up. Yeah, that's it. Yeah, a lot of cherry picking there, but thanks. Yeah, do we have time for questions?
Sure.
Okay.
So I would like to challenge you here and in the room and anyone listening in. Does anyone have in your mind when you're just daydreaming and say, I wish I had a software that could do what? So who has ever had that thought, and what is that thought?
Well, I've had lots of such thoughts.
I'll bet.
Yeah. Well, the one thing that I want is something that can take, maybe I'm playing a certain chord, and then I like save that, and then play another one and have all the notes slide to the next chord, basically. That's kind of a simple.
So one morphs into the other automatically type
Yeah,
thing?
yeah.
Okay. That's,
Like an interpolation between two chords.
so you can whip that off in another day or two.
Yeah, of course.
Oh,
One that kind of follows your first presentation. I wish if I could just do, like how conductors like scat, like da da ba ba boo ba, just like get the idea of something across.
Yeah,
If I
yeah.
could do that in it with maybe a little bit more tone, but it translates into onto a score written out music, because like I can't express myself, so maybe it writes in all the pianos and the crescendos and things. A lot easier to punch in.
No, yeah. That's it's called automatic transcription. There's stuff there. It's similar to what I'm doing. I'm more doing like exploratory sound stuff, but it's definitely a research area. Yeah. I don't know how well it is, but like how good it is. Not how well. But yeah. It's an interesting idea as well. Yeah, it's another problem. I mean, it's please don't look at me as like the solver of all your problems now. I need to do my PhD. I'm working, but thanks for sharing. Yeah, it is a nice idea.
well, my hope is that someone else will say, "Oh yeah, I can do that."
Yeah, I mean, well, Irmak is
I think there's like good enough models that can
Yeah.
transcribe audio into MIDI, so that's called like MIDI transcription. Not necessarily sheet music though. That takes like everyone's gonna be a while. But
So
yeah, there's
just
more
for context a little bit, Irmak she's doing her PhD with Chris, and she's looking at musical score alignment with sound. So like you play like the same song, different covers. Correct me if I'm wrong, right? But like same song, you have different covers. If you can align that always to like the same score, for example. But yeah, it's a hard problem.
Yeah, sometimes I wish the inverse, that I have a MIDI, and in that MIDI I don't have any articulations or any expressions, but I want some tools to generate those things for me. Yeah, I don't want to just draw the expressions all by my head.
But do you mean like the sound, or do you mean the expressions like the musical sheet, like the crescendo and stuff, or?
Not necessarily the sheets.
Okay.
But sound is also useful because my final target is sound actually.
Yeah.
Yeah.
Okay. Well, I don't know if you're thinking about drums specifically, but there was this work, and I hid it because I thought, it was a lot here. But so these guys, this is a work called Learning to Groove, and yeah, I think you're talking about like this difference here between just the MIDI of like the score. This is the drum track, right?
Yeah.
And then this is the performer, so it has the groove, it has the
Yes,
feeling of it. And they were trying to they call this task like from score to performance humanization, kinda. And I haven't, I'm more focused on this task of I have one class of hits, right? And I want to like demultiplex it into the full drums. So I don't really know how well they did on this task and if there was like anything after that from them, but I can, maybe you can look for it.
Okay, who else? Oh, okay.
I also kind of wish like a similar tool of what you described exists, because like, for instance, like I like programming drums with MIDI. It's a lot easier that way, because like, you can also hear the instant feedback too, and then you can also do automation with it. But then like one time, like I kind of did that to figure out like a groove I want to do for one orchestration project, and then immediately when I tried to pull it back, like do it until like what's that called, like music score, I eventually run into a ton of problems because I need to figure out like how to like do things in the music score way to write these things out correctly, and then how to write out in such a way that makes sense to musician. So I kind of wish like there was just a tool that would just like interpret like what you put into MIDI and like the sound, and it just turn it into a classical score that it's not like a perfect one, but at least a good suggestion that I could work off.
Yeah. Yeah. I mean, again, I'm not your solver for now. Still need to do my
something
PhD.
Like, it's written like this, but it should sound like that.
Or it's more like it sounds like that, but I want to make it into a score that someone can read. Because I guess like I also have a friend who like he just like comes up with a lot of great ideas with like music and all often do improvisation, but he doesn't really have a background in like writing music, so he often struggles with like turning it into score that like makes sense for musicians to play. So I just kind of wish there's kind of a tool that could take what he already created by ear into some kind of score, and then afterward he can just like sort of modify that score so that he can give out to musician and turn into actually a recording.
So yeah. Just,
okay, anyone online watching from from Zoom? Anyone there?
I have one question, Ricardo. This is Nick. First of all, André, I found your presentation fascinating.
Oh, thank you.
I'm not sure I was smart enough to absorb it all, but that's not important, actually. What I really liked about it, you focused on the artist's needs. And here's my question. And I'll use the hypothetical case of a drummer. If a drummer comes and says something, and I want to implement your work, how do I answer that?
Wait, so you're saying that somebody wants to implement my work
in their drumming, in their whatever they're doing some sort of project with drumming. I would like to be able to tell them how to contact you, or it doesn't have to be technical. It could be whatever.
Yeah. Well, to contact me, you can just email me. There's the QR code is over here.
Okay.
It has my email. I guess I can maybe share the slides. I don't know.
I don't need the answer. I just want to know directionally, because it sounds like this is very useful stuff, but I don't want to screw it up in the translation.
Yeah. No. The other thing is like research is very different from like the finished products, right? Like getting.
So is it too early?
Yes.
Okay, that's okay. That's okay.
But thank you.
I'll wait till the next seminar.
Because it's a whole other thing of like productizing. This is a whole other area, and I'm not even like my background is not from computer science. Like.
Okay, I can accept that. Thank you.
Yeah, no worries.
So let's go to the other mode so we can see all the people who are here.
And well, I have to stop sharing, I think.
Oh, we have a big crowd. Nice.
Yeah.
Okay. Is there anything in the chat window that we need to look at? Yeah, there's something.
Oh, Roger puts my mail. Yeah, my mail is in the chat. Thanks, Roger, for that.
Okay. Does anyone else have any questions, comments, or ideas?
So to clarify, Boca was just a WhatsApp number that people could like text to,
yes,
and then you just like observe what they were looking for.
Yes.
Okay.
At the end, yeah. And also, it was a kind of annoying because it was always tell them like, "Thank you for your input. I'm sorry I cannot help now." You know. So that's why
Eventually, the artists were not using this.
Yeah. But like, I think it would be cool to kind of rerun that study again, but now with ChatGPT somehow involved, or just or just the fact that ChatGPT has like entered the lives of these artists and stuff.
Okay, someone has a hand up over there.
Oh yeah, Juliana. Hey.
Hey, really great work. It was very interesting to see
Thanks.
The progress made on this and to hear the quality of the drums, how you're able to create that from a beat. I was curious to learn more about the variations of the drum sounds that you used to train the model. Did you notice they have to be very similar, or if they were different, was that still productive?
So the data set I used is called Groove MIDI dataset. It's from that work I was just telling you guys about, the Learning to Groove by Gillick et al. In terms of you mean like variation in the types of sounds, right?
Yeah, that's correct.
Yeah, I think there's some variation. There's not a lot, and actually there was a subsequent work where they extended that data set to have more different types of sounds, of drum sounds. This is more, so the way they did the original data set, the one I used, was they plugged an electronic drum kit, and then they just recorded from there. So it's actually like high quality synthesized MIDI, I think. So I guess the short answer to your question, no, yes. The short answer to your question is there could be more. There is somewhat, and I might. It might be a good idea to try and train the model again with some more different types of sounds.
So I was going to ask, André, do you need to sample some drum sounds?
I might actually need to sample some tap sounds, but yeah, I might survey you guys for some tapping from some.
Okay, well,
but
knowing
see.
what goes on when I'm teaching class, there's
Yeah.
a lot of people who are with these nervous things, and
Yes.
they've got some idea in their mind and some
Yeah,
rhythm,
yeah. No,
and they're tapping it out.
I
so
get it because I'm like that. So
Should we just wire them up?
maybe. Juliana, did I answer your question at all, or?
That answers my question. Yeah. And
Okay.
just a brief follow-up. In terms of the variation, did you have variation for rhythm or just the type of the drum?
No, yeah.
The minimal variation that you did have.
No. It was also different rhythmic patterns.
Okay.
But I guess it doesn't really matter because rave is not. It's learning the sounds. It's not really learning the structure, I think. But pretty sure.
Okay. Really interesting work. Nice.
Yeah. Thanks. Nice hearing from you.
Yeah.
Oh yes.
Yeah, I really like seeing the visualization of the data that you had.
Yes.
And I'm wondering if you think that, first off, more data would provide better results, and how like the noise of just the ambient, room affects the output.
Well, it should affect, but the noise regarding the training data, you don't want that. Well, at the same time, actually, yeah, I need to read up a little bit more
Is
on
there a
that.
gate or
because,
something on it that keeps that from?
A what? A gate?
Yeah, just like to isolate the sound, maybe.
Oh yeah, I don't know about the data set I used. Actually, I was saying that you don't want noise on data, but sometimes you want, because that makes you. That's called data augmentation. That makes you have artificially more data to train on, because the model learns how to like ignore the noise, and it's also like you can like multiply the same sample, but. Yeah, the first question I forgot. Sorry.
Do you think that more data would provide better results?
Probably. Like in deep learning, almost always more data will result in better stuff. I think it would maybe improve the clusters even more of like the snares, the kick drums. What I was actually discussing with a colleague of mine today was and that's why I was talking about taps, is that you can maybe train the encoder for this tap system, so that for this tap sound, so that it learns instead of that purple cluster that we were seeing. So maybe this gets split somehow if you train on the tap sounds, but then the decoder, what you want, and in the end are drum sounds or percussion sounds. So you then need to train that on drum sounds or whatever type of sounds you need. But that's something I might look into. I think there was a hand up, or maybe not.
You have a question.
Oh, sorry.
Yeah. The question I have is that, for example, when the low, we have an example of the low tom and the bass drums that is really similar, but in the real case of music production, often the distinguished condition of our hearing is in the context of music. Yeah, for example, when there is a lot of like somehow bass sound-ish sound that's with increasing pitch, we will notice it as a tom instead of the drum, bass drum. Yeah, but according to your previous answer to that, to the Zoom, I noticed that you said that this model does not care about context.
Not really. It's more, so that's a very nice question, because it's very much an audio to audio model, and it just cares about how does the sound.
Yeah.
Like, well, how do you use audio? But I do get, you can go ahead.
Yeah, and if it's in tapping situation, sometimes we don't really make the difference of sound, but the difference of rhythm.
Mm-hmm.
And the reason why we are categorize it as like bass or snare drum is because it's on some particular
Yes. Mm-hmm.
Instead of
Yes, that's totally true. It's a very nice point. Of course, I've already thought about that a lot, and I might want to do that to essentially do that, to discern of like, okay, what this that I'm doing, like where's the downbeat and stuff, what's the kick drum in this little rhythm I did, what's the snare or whatever, right? I think I want to do that, but I think there's a a way in which I don't need to do that, and it might be better, if that makes sense, like for the computer at least. Because I want to do that because, I also think like that, it's intuitive, but I'm not sure it's the best way. I have to see.
I was just curious, and this might be something that like you would think about way later in the stage, but with something like polka, do you take into account like licensing or permissions with that? Like if an artist said, here's like the beginning of a piece, or here's an idea for like the type of piece I want, just make it or finish it. Is that something where you would be like, oh, well, this is yours now? Like you made that, like you can put your name on it? Or?
It's a very, hot topic, and the legal aspect of it. We were just thinking about like, do you want it or not? And then like, that's something to discuss later. So we didn't really think about any of that. But it's definitely,
Yeah, I was just curious.
Interesting. No, and I don't know what to tell you. It's because
that reminds me of an interaction that Roger had with some. Roger, do you remember what that was? Where you were manipulating sound in some way? It was an interview of a national broadcast of some type, and the question to you was, well, who owns it after you've done that? And you didn't hesitate to say, I do.
Yeah. Right, that was for a Science Friday show on AI and music, I think. But I think, and the question was if I write the code and I create something with it, who owns the copyright? And my answer was I do. It's a little different if if you're asking a company or ChatGPT to do something for you, then who owns the result? But I think my opinion is it's very much like if you use samples that were recorded from musicians, obviously they produce the sounds. Do they have ownership in what you create? And the answer there is that, well, if you paid for the sounds and the musicians got paid and everybody signed agreements, then everything's sort of already worked out and signed on paper that you own the music because you use these sounds under license and you don't. So that's. But like André says, it's a complicated situation. You can probably generate different situations forever that have different answers.
Yeah, I also like whenever I start thinking about that and like the who owns it and stuff, I'm like, this is too complicated. I don't want to think about it. I should and I need to, I guess, as somebody who works in the field. But,
and a lot of people don't realize, and I just learned this not too long ago, and I thought I was completely amazed by it, is that there's not only copyright, but there's a thing in the U.S. called right of
publicity, which basically means, to give a concrete example that actually went through the courts, if you're Bette Midler, and you sing a certain, you produce an album with a certain kind of arrangements and you have a certain kind of voice, then if, in the particular case, if Ford Motor Company decides they want to imitate that and produce, totally new music with a totally different singer and different band and arranger and everything else, but it just sounds recognizably like Bette Midler, she has rights in that, and she sued Ford Motor Company and won, a considerable settlement because they were using stuff that everybody probably thought was her in advertisements, and she didn't want that.
Yeah, I guess a nice or a good person to ask about that stuff is Shushi too, right? Your student.
Yeah, she's been looking at it. I mean, we all have a lot to learn, but that's in fact, speaking of her, if the announcement went out to the music technology mailing list that I think all of you are members of, and so you got the announcement that her thesis proposal is tomorrow at 1:00, and feel free to mail me if you didn't get that, because you might want to be on the list.
Are you speaking directly to me?
No, to everyone.
No, okay. No, I got it. Okay.
I just added you. I thought about you, added you to the list just before I sent it. So it's a good test. Okay.
Yeah.
Okay, unless there are any other questions, I think we can call it a night and thank André one more time.
Yeah, thank you.
So we can stop recording now.